All right. So, like I was saying, fractions are typically a tricky thing, and so with these problems here, what I'm going to do is I'm going to try to come up with a common denominator first, right? Since we're adding and subtracting here, we want to do a common denominator, and so for each one of these, I can see quickly that the common denominator is 18, right? 6 goes into 18, 9 goes into 18, and so 18 should be the common denominator. If you don't know what the common denominator is, one of the things you can always do is go find the least common multiple. So this would be 6, 12, 18, 24. This would be 9, 18, 27, 18, 36, and so on. And you can see 18s in all of them. And so we know that that is the common denominator. Now, with the 6, to get 18, I needed to multiply by 3. So I'm going to go 3 times 6. So that means if I multiply the bottom by 3, I have to multiply the numerator by 3, right? Plus, I'm going to multiply the 9 by 2. So that means I should multiply the 2 in the numerator by 2. And then I'm not multiplying anything to my 18 because I've already got I've already got the denominator that I desire. And so now getting the common denominators, I'm going to get negative 15 over 18 plus 4 over 18 plus 7 over 18. And now when we add these up, a negative 15 plus 4 plus 7, we see that that's going to be a negative 4 over 18. Is there any questions on how I got negative 4? I know I might be going fast there, so is there any questions on how I got that? Okay, I'll demonstrate it because it's worth getting. All right, so we're going to have negative 15 plus 4 plus 7 for the numerator, correct? All of that goes over 18. So if I just deal with the first two, right? And the way I like to think about negatives and positives, I think of it as like owing money. So if I owed my brother 15 bucks and I paid him $4, once I pay him $4, how much do I still owe him? Don't I owe him still 11? Yeah, so oops, sorry, let me change it. I still owe him 11 bucks. And then if I owe him 11 bucks and then I give him another 7, now I still owe him $4, right? And that's how I got that negative 4. Does that make sense, Paul? Okay, good. And then the other way, right, if I go 11 minus a number, no, I'm going to do another example. Don't worry, I will. And then here I need to reduce this, right, because 4 and 18 are both even, so I can reduce those, and when I reduce them, I'm going to reduce by each of them by 2, so I should get 2 over 9, and that is my answer. Does everyone get the reduction there, how I did the reducing, or shall I show that also? I don't mind. All right. Well, let me make another problem up. Show how you do. Okay, I will. So the way I look at it is they're both even, so I'm going to go 2 times 2, and I'm going to go 2 times 9, right? Because that's 18 and that's still 4. And since those are the same, they cancel out, and I get that. Does that help, Paul?
Yeah.
All right, good. I'm grateful that you're asking, actually. I don't know if people ask questions. And
I had a hard time with this one, that's why.
Oh, okay. Cool. So let me make another one for you, all right? Don't want to go too crazy. Okay, so in this one here, what would our common denominator be?
20.
It'd be 20, right? So 20 is the common denominator. And so I'm going to go, all right, 4 times 5 gets me 20. So I should go 4 times 4 minus 5 times 4 gets me 20. So 5 times 3 plus 2 times 10. So I got to go 2 times 1. And the reason I like to show this step is so everyone sees that I'm multiplying top and bottom by the same thing so that my fractions are staying the same. So I'm going to get 16 over 20 minus 15 over 20 plus 2 over 20. And then I'm going to go 16 minus 15 plus 2 all over 20. And left to right, so let's deal with this first. So what's 16 minus 15? Right? I have $16. I want to buy something that's 15 bucks. Do I have enough money? And if I do I have too much money? So in this case, it turns out I have more than enough money, so I can buy the thing and still have $1. So I'm going to have 1 plus 2 over 20, and that's going to be 3 over 20. Now, can that be reduced?
No.
The answer is no. Does that make sense to you, Paul?
Yeah.
You feel more comfortable with it now?
A little bit.
Okay.
A little bit more.
All right. But that's the process that you're going to do. The big thing is finding what the common denominator is, right? Like we did here. Once you find the common denominator, how do you make each one of the fractions have that same denominator? And then that'll help you solve the problem.
All right.
Okay? And if you have any questions on it, shoot me an email. I can Zoom with you real quick to try and give you more clarification individually.
Yeah, because when I was doing it, I was having a hard time.
Yeah.
I don't know how I was.
Shoot me an email. I can, from this program, I can even send you a small little video of me explaining it.
Oh, okay.
Okay? So, like, even if we can't Zoom, I can email you a little video that just shows you how to do the problem.
Because I skipped it. I skipped this one. There was other problems I was doing. And then after I did some other ones, it told me to do this one. And I couldn't do it, and I just skipped it.
Got it. Yeah, so next time that happens, or come to my office hours, right? Either way, I want to be able to help you.
All right.
All right, cool. All right, let's do this next problem. And now we're talking about multiplication of fractions. So what's cool about multiplying fractions is we just multiply straight across, right? So in this example here, nothing can be canceled. So what we can do is just write 4 times 2 over 9 times 5. And what is that? It's just 8 over 45, correct? That's how easy multiplication of fractions is. Okay, so if I gave you something like 5 over 6 times, I don't know, 7 over well, I'm going to show you this one. This, what would this be? If we multiply straight across, I'm going to get 35 over 60, but then that can be reduced. So I'm going to show you a faster way to do this. That would have been 7 over 12, I believe is the answer. Let me show you a faster way to do this. And in fact, just to prove that it's 7 over 12, that's the same as 5 over 7, 5 times 7, and this is 5 times 12. The 5's cancel, and so I get my answer. The other way to do it would have been to, if this is the problem, let's rewrite it as 5 times 7, and then what we could do is break the denominator down. So I know that this is 2 times 3 times 2 times 5, right? What's in both? Isn't 5 in both? And since 5's in both, I don't need to multiply by those. They're going to cancel, and I'm going to get 4 times 3, and 4 times 3 is what? Does that make sense? Do you guys have any questions on this, or are you guys okay? Okay. Let me give you one more to try, and we'll go from there, okay? Try that one.
Over 3?
Did you say 2 over 3?
Yes.
Okay. Let's see. So if I multiply straight across and do it that way, I would get this, correct? From here, I see 6 goes into both. So that actually better than 6, 12 goes into both. So it's 12 times 2 over 12 times 3. And so I get 2/3. That's one way to do it. The other way to do it would be to go, okay, that's 3 times 2 times 2 times 2 over 2 times 2 times 3 times 3. And if we look at it this way, there's a 3, there's a 3, that's gone. There's a 2, there's a 2, that's gone. Here's a 2, here's a 2, that's gone. And what we notice is the only thing left is 2 over 3. I tend to not like to work with big numbers, so I tend to break down my numbers into prime factors to help simplify things. Does that make sense? Okay, let me go on to the next example. And now what we're doing is we're going to try to simplify this, but now we have a mixed number. So when we have a whole number multiplied with a mixed number, isn't the whole number the same as 8 over 1, right? And the mixed number is going to be written as, that's 18, I believe that's 23 over 6. I showed you guys how to do this. Would you like me to show you again how to make a mixed number into an improper fraction? Or do you guys recall?
Can you do it?
Yeah, no problem. So I'll do it in chunks so you can see it, okay? So it was not 2. So it's 3. I'll make my denominator the 6, and I'll make the 5 come into play. And so here's what happens. When I have this fraction, gotta fix that. We go this way first. So this happens first. And what I do here is I have to multiply. So 3 times 6 is what?
18.
That's 18. And then what I do here is second. And what I do here, when I do second, I just add. So we said 3 times 6, and then we're going to go plus the 5. And we said 3 times 6 is 18 plus 5. That gives me the 23. That is going to be my numerator every time. Does that make sense? The denominator never changes. So my denominator is 6, the denominator stays 6, and so I get 23 over 6. Are we okay?
Yeah.
All right, cool. Now, here's why I want to break down my numbers, because 8 times 23 becomes something crazy big. I don't want to deal with something crazy big. So I'm going to break down the 8 to be 2 times 2 times 2, right? Times the 23. And then I'm going to have 2 times 3. Well, they have a 2 in common, and that's it, right? So what ends up happening here is my denominator is going to be 3. And my numerator is going to be 4 times 23. And 4 times 23 is 92. Right? So if they let you write it as a mixed number, they say write your answer as a mixed number in simplest form. So we have the right fraction, but now we need to write it as a mixed number. And so to write it as a mixed number, I have to divide it. So I'm going to divide it. So how many times does 3 go into 9?
3.
How many times does 3 go into 2? It's clearly 0. So this will be my whole number. What's the remainder?
2.
It's the 2. And then what did I divide by?
3.
I divided by 3. So this is the answer. Is that okay? Should I do one more?
Yeah, can you?
Yeah, no problem. All right, so let's say I give you 5 times 2 and 1/3. So the first thing we need to do is change that 2 and 1/3 to an improper fraction, correct? So can you guys do that for me?
Seven over 3.
Okay, that's right. So I'm going to get 5 over 1 times 7 over 3. Is there anyone that had an issue getting that 7 over 3? Please speak up. I'll show again how to do it. All right, well, I'll just show it. 2 and 1/3. So this is multiplied. So that's 2 times 3. And then this way I add. So I got to add 1. So I'm going to get 6 plus 1, which is the 7. That's the numerator. And then what did I divide by? I divided by 3. Now here, 5 is a prime, 7 is a prime, 1 is a prime. Well, 1's not a prime, 1's its own number, it's an identity. And 3 is a prime. Since they're all primes, the only thing that I can do is multiply across. There's nothing that can be canceled. And then from here, I need to do my division. So I'm going to go 3 and 35, so it can go in once. 0, how many times does 3 go into 5? It goes in once. My remainder is 2. So my answer should be 11 and 2/3. Does that help?
I'm getting it.
All right, good. Okay, now to throw in another twist. Because all of these kind of have the same properties, I'm going to throw in the other twist for you. Now instead of multiplying, we're going to divide. Okay, so first thing I want to do is take this mixed number and change it. And so 28, that's going to be 34 over 7 divided by, and I'm going to go 9 over 1. Does everyone agree with that being 34 over 7?
How you got it again?
Sure.
Dan? Yeah.
So what's 4 times 7, right? 4 times 7 plus my 6. So here's times, here's plus. So I believe that's 28. And that gives me my 34, right?
Okay.
Okay. Now the important thing is when we divide by a fraction, and any number that we divide by is a fraction, we can write it as a fraction, right, over 1. We need to change it to multiplication and flip the number that follows a divide. Does that make sense? So that 9 over 1 becomes a 1/9. Okay? And so let's see if we can break down this 34. So I think it's just 2 times 17, right? Yeah. 2 times 17 over 7 times 9. Are any of those able to cancel? The answer is no. So it's 34 over 63. That is the answer. And since the numerator is smaller than the denominator, that is your answer. You okay?
Mm-hmm.
That's called the reciprocal, right? That's right. We reciprocate by flipping it. All right, let me give you one more. So let's say I gave you 2 and 5/6, and I divided by, I don't know, let's say 3. What is the mixed?
Oh, wait. I have a question.
Sure.
How you got 2 times 17? I'm looking at it right now.
Okay, no problem.
How you got?
So 34 is an even number, correct?
Mm-hmm.
So the smallest number that goes into it is 2, correct?
Mm-hmm.
So 2 times what is 34? So in my head, I went, okay, let's see. 1, 14. How many times does 2 go into 14?
Alright.
Right? How many times does 2 go into 14? What do you think, Paul?
Say again? I think you break out a little bit in my end.
Oh, I'm sorry. How many times does 2 go into 14?
I'm trying to think. I'm like half asleep right now.
Oh, no problem.
I'll be honest, I don't even know right now.
Okay, no worries. It's 7. So 2 times 7 is 14. We have no remainder, and so I know that 2 times 17 is 34. So that's how I got the 2 times 17.
I was just looking back, and I'm like, how you got those two numbers?
Yeah. But that's it.
Okay.
Okay, Now here, this mixed number, when I go to change it to an improper, I'm going to go 2 times 6 is 12, plus 5 is going to give me 17 over 6, and then I'm going to divide by 3 over 1. That's going to become 17 over 6 times 1/3. And 17 is a prime, so I can't break that down. So that's going to be 17 over, what's 6 times 3? 6 times 3 is 18. Since the numerator is smaller, that is the answer. Does that make sense?
Yeah, I'm getting it now.
All right, cool. Cool. So these are the 4 topics that I wanted to address today to try to help you. I'm going to stop recording just so I don't make this too crazy long, and then I'll answer any questions you guys might have for me, okay? So let me stop this recording.